Section 7 is all about scatter plots. Working with data. And then it says also trend lines. Trend lines are what we put in on top of the data to make it make more sense to us. So we can hopefully come up with an equation to model the data and then use the equation to predict things down the road, like future events. So we need to come up with some vocab here. Scatter plot. Scatter plots are just graphs of data. That's it. And your data is just going to be ordered pairs only. No lines, no little curves or anything, just dots. A line of fit is a line that we draw that seems like it fits the data that we see the best. So, line of fit, a line we draw that seems to fit the data. Of course, we want to make that line of fit the best possible line. So we're going to really try to draw that line in there well. But it's just a line that fits the data. Correlation is how strongly one variable relates to the other. So how well one variable relates to the other. We're going to talk about correlation here in a little bit to give you some examples. So in this section, we're going to create scatter plots from data. We're going to draw lines of fit from the scatter plot that we made. Then write an equation for the line of fit by picking a couple points on that line. And then using the equation to make predictions. So once we have the equation, we'll say, what's going to happen in 5 years from now? Something like that. So I want to talk about correlation. We have two different types, positive and negative. Or, if there's no correlation at all, no correlation. We also have weak and strong. Sometimes if you're comparing two graphs, two scatter plots, you can say that this correlation looks stronger than the other correlation. So I'll show you that too. For a positive correlation, if I have a positive slope on a line, that line goes up from left to right. For a positive correlation, I'm going to have data that seems to go up from left to right. So when I graph it, I'll see something like that. For a negative strong correlation, a negative slope would be like my line goes down from left to right. So a negative correlation is the same idea. My data will all be making sort of a line that goes down from left to right. If I have no correlation, you see that word cloud there, that's just a bunch of dots that really have no rhyme or reason to them. I can't really put any sort of line in there. Like I could maybe draw a line like this, but I could just as easily draw a line like this, or a line like this, or a line like this, or a line like this, and really none of them are going to make sense for the data. Not nearly as good as this stuff is. You can see a line here. You can't see one here at all. That's no correlation. The data looks like a cloud. Now this is the positive, strong correlation. We can't say strong until we have something to compare it to. So I'm going to give you another scatter plot of a positive correlation, and we'll see the difference right away. Okay, does it seem like if I drew a line in there, that line would go up from left to right? Yes. But notice how much more spread out this data is compared to this data with the same scale. This is much stronger correlation than this. I'm still going to be able to draw a line in that thing. But because this data is so much tighter, when I draw in that line, I'll go ahead and do that. Let me draw in a line right here and show you what I'm talking about. All of those data points are real close to that line that I just drew in. Now I draw in another line here that seems to be kind of matching up the data as best as possible. And look at how much more spread out those dots are. Okay? That's the difference between strong and weak. You can't really say strong or weak. You can say positive for sure, but you can't really say strong or weak unless you have something to compare it to. And it needs to be the same scale on your axes. Because I can make anything look strong or weak just by changing the scale. Negative strong becomes a strong correlation when I compare it to something that's negative also, but the dots are more spread out. So again, if I were to draw in a line there, you can see that for the negative strong correlation, all of my dots kind of match up with that line I missed, but that's the idea. And then for the negative weak correlation, all of my dots are much more spread apart. It's still a negative correlation, but it's a little bit weaker of a relationship. Now, no correlation over here, some other type of no correlation, you might see something like this, where there's a dot here, dot here, dot here, and then a dot here, and a dot here, and a dot here, and then another dot here, here, and here, here, and here maybe. There's no real correlation there either. I could probably draw on a line that maybe does this, or this, but really I could probably draw on a negative slope on that also. No correlation here either. All right, we're going to get some practice drawing scatter plots now. Read the problem. It says the table shows an altitude of a plane and the temperature of the air outside of the plane. Make a scatter plot of the data and describe the relationship of the data. Okay, so we just basically want to plot all these points, which means we need to come up with a scale. And we need to figure out what's going to go on the x-axis and the y-axis. And we need to figure out where our origin is going to go. So look at the data. Where can I put my origin? Bottom left corner, because I don't see any negatives on either sets of data. So I can put it all the way down in the bottom left corner. And what is going to go on the x-axis? Altitude or temperature? So the question is it the higher I go that makes the temperature fall? Or is it the lower temperature tells me what altitude I'm at? The higher you go, the lower the temperature falls. Okay, so what goes on the x-axis? Altitude. And that altitude is in meters, not feet. Okay, so then the temperature goes over here, and that's degrees Fahrenheit. Now I got to come up with a scale, and this is nothing we haven't done before. We've been doing this all year long, so this should be okay. Scale for the altitude axis, we start at 0. We have data at 0, so I can't break the graph. We have data all the way to 5,000. Go by 500s? That would get me to 5,000. Okay, so we'll go by 500. And then I'm going to mark every other at 1,000. 1,000 here, 2,000, 3,000. I'll skip 4,000. 5,000. Okay. Now a scale for the temperature axis. What's our highest temperature? 59 degrees. What's our lowest temperature? 0.6, just about 0. So again, I can't break the graph here. I have to go all the way to 0. I have to go at least to 59, so probably more like 60. What's going to be a good scale here? Tens, yeah. So 10, 20, 30, 40, 50. There's 60, and we're good. Technically, we could have gone by 5s, I suppose. Yeah, we could have gone by 5s. And you really should. You should try to spread out your data as best as possible. We already have 10s on here, so that's fine. All right, now you just graph all of these dots. So we have 0, 59, which is all the way up there. 500, 59.2. And then 1,000, 61.3. Do the best you can with these dots. 1,500, 55.5. With our scale, we're pretty much only going to be able to graph like the 55. Don't worry about the 0.5. 41.6 for 2,000. Okay, the next one. 10, 20, 29. And then 3,000. 3,500. 4,000. 4,500. And 5,000. So now overall, we saw that the temperature went up and down kind of as we were going along. But overall, does it seem like the temperature is falling the higher up you go? Yes. Okay. So it says make a scatter plot of the data. Does it say draw a line in there? No. So we don't. This is all we had to do here. But then it says describe the relationship of the data. So there's two things we're going to say here, because it doesn't specifically say what type of correlation or in words what is the relationship. So what I'm going to say first is this is a negative correlation, because it's falling from left to right, so that's a negative correlation. But in words, what is going on? Give me a sentence that states what's happening. Let me start it. As the altitude increases, finish my sentence. The temperature decreases. Good. Okay. So when they say describe the relationship of the data, that's what we're looking for. It could be either negative correlation, or it could be as the altitude increases, the temperature decreases. In this case, I definitely want both. And for you guys, just do both. It's easy. Line goes down from left to right, negative correlation, no brainer. But then the sentence makes you think a little bit, so that's the important one. Here's the next problem. We'll read it. It says, make a scatter plot and describe the situation. What are we doing in this data here? So, go ahead, Ben. How much money you spent on gas. That's right. So, even though there is no story going on here, it just says do this stuff. Just from the data and the labels that they have on here, you know exactly what was going on. We're paying money at the gas pump. We're filling up our gas tank. Okay? So, we want to make a scatter plot and describe the correlation. Now, what do? Which one's X and which one's Y? X is gallons. Good. And Y is dollars spent. The more gallons I buy, the more money I spend. That's pretty straightforward. So what do I do now? So on the graph, what do I do first? Bottom left. How come I can go in the bottom left here? Can't have negative gallons, can't have negative dollars spent. Now what? Labels. So what goes here? Gallons. And that's number of gallons. And then on the y-axis, so money spent. Now what? We need a scale, so let's look at which axis first. Okay, x-axis, what's my scale going to have to be? Oh, that's 1.3. So we're going to start at 0, and the highest we have to get to is 3.3. We have 14 lines here. Go by halves. So that'd be 1, that'd be 2, that'd be 3, and then I'd be about there. If I go by quarters, 1, 2, 3, 1, 1, 2, 3, 2, 1, 2, 3, 3, 0.25, 3.5. That actually fits really well. So let's do that. We're going by quarters, so 0.25. And I'm going to put 1, 2, 3, and then obviously 3.5 at the end. All right, now let's come up with a good scale for money spent. Yeah, by ones. We got to make it all the way to 13, and we have 14 lines here. We go all the way down to 4, so starting at 0 is going to be fine, and we'll just go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 14 all the way at the top. Now what? Okay, so let's get all the dots on there. So here's your scatter plot. Now notice that when we put these dots in here, the x variable here was the number of gallons. We know that that's right, but look at the chart. We have dollars spent on top and number of gallons on the bottom. That's okay. We know for sure that gallons must be the independent variable, okay? So when you're graphing this, just because we have dollars on top and this on the bottom, that doesn't mean that dollars is the independent variable. You got to actually think about it. So this one was kind of tricky because they reversed what you would normally expect. Now, let's answer the question. It says make the scatter plot. We did, but we need to describe the correlation. What kind of correlation do we have here? I don't want to say strong or weak because we don't have anything to compare it to, but it is definitely positive. Now, let's put a sentence down here. As what? Okay, let's get rid of as, and I like that. The more what? The more gallons you buy, what happens? The more money you spend. No duh. But that is what they're looking for. Okay? Okay, we have this second part right here. It says, consider the population of a city and the number of letters in the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation between those two sets of data? No correlation. Why? It has nothing to do with the number of letters in the name of the city. Right? Look at London. 6 letters. Look at San Francisco. Lots of letters. Both of them are major, major cities. Right? But if I find a town called Rancho Cucamonga, California, that's like 80,000 letters. Does that mean that there's 12 billion people living there? No. Okay? So there's no correlation here. Because it shouldn't have anything to do with the number of letters in the name.